Good evening, everybody.
Good evening.
How are you today? Good, good. So, are you ready for the test? For the upcoming test? Okay. For the upcoming test, so your next lecture will be test 2, right? Okay, we will start just right 6:45. Okay, we will start our test at 6:45. So 45 minutes. Okay. Let us make it 6:50, right? Okay. So if you are late, but come by 6:45, okay? Okay, so in your test, excuse me, please. Give me attention. Give your attention to here, please. Okay, so in your next lecture, we will have a test, right? Test 2 we will cover from content week 4 to 6. So let us see week 4. We started with inheritance, then we discussed polymorphism. There are two types of polymorphism, right? So what is an inheritance? Inheritance is a process or a technique that allows us to extend a class with an existing class, right? Okay. And then we discuss polymorphism. There are two types of polymorphism. Okay, actually method overloading and method overriding, right? Method overloading happens within a class. A method with different parameter types or parameter list but same name. Okay, and method overriding happens within parent and child classes. Parent and child classes. Then we discuss abstraction with abstract class and interface, right? An abstract class Z is 0 to 100% abstract. In an abstract class, you may have all method abstract or at least one method abstract or nothing abstract. Without having an abstract method, you can create a class that is an abstract class. Usually an abstract class contains an abstract method. What is an abstract method? Method that does not contain any implementation or any body, right? So who contains the body or implementation? That the concrete class, another class that inherits this class. If a class inherits an abstract class, that the inherited or child class must implement all abstract method, right, within any class. So an abstract class cannot be used to create an object of its type. An abstract class may contain a constructor, but that constructor cannot be called. And then we discuss interface, right? What is an interface? Interface is another contract, a contract between a class. That if you have an interface that is 100% abstract, all methods in an interface is by default abstract, right? You cannot have any body of an interface. You may inherit from multiple interfaces, right? But you can inherit only one abstract class, right? That is the difference. Okay, we discussed this. Sorry? Interface is a contract. It is called something. If you do Google search, there is a kind of contract. Also an abstract class is a contract. If you have an abstract class, then you must implement that unimplemented method, right? Similarly, an interface is 100% abstract. Everything in an interface is abstract.
Can it have variables?
Yes, you can have variables that is actually called field in an interface, but that must be initialized. Put a value. Okay, but there are some differences between C Sharp and Java programming languages. How do we implement abstract class and interfaces? So, and in my replit, I have some programs that we discuss. There we discuss, for instance, inheritance vehicle. Example 1 with C Sharp, with Java, which I have with C Sharp and I have with Java, and then I have abstract class and interface vehicle with vehicle subclass, and I have this also with what is that? I have this code in Java and C Sharp as well as all programs, right? I wrote it in Java, and you know Caesar, right? Caesar. Caesar helped me to convert it in C Sharp. These are the program, and I put it in this. Okay. Oh, this one. These are in C Sharp, and these are Java. Okay, and we also discuss string operation with C Sharp and string operation with Java. So these are the program. If you practice this program, string operations, and then abstract class, interface, and inheritance, these three programs. In some of these programs, we also discuss static modifier. Right? What's static? How to declare a class static? Sorry, how to declare a method static? What happens we declare a method static? We discussed this, yes. So if you review these few programs, like 5-6 programs, you should be good for your test too. There is nothing to memorize for your test. There will be 6 questions and you have to complete in 45 minutes. If you practice this programming, then it should be good. You will be able to complete this in 30 minutes. But if you do not practice this programming, you will not be able to complete in 4 hours. Yes, you have a question? You have a question?
No, you asked something and I had an answer.
Okay. So anyone has any question about the test too? Yes.
When it comes to the string manipulation, are we going to have to specify whether we're doing it in Java or C?
No. If you mention C Sharp then or Java, then fine. But when we grade, we understand that there is difference. Yeah, whatever you write, we will understand. So either if you write your output in C++, in C Sharp or Java, that's fine. Okay. But if you can mention that, fine. That will be awesome. Yes.
For the test, how are we going to write down the GUI for C Sharp?
What is that called? C Sharp? What is that? GUI programming?
Yeah.
Okay, for GUI programming, you will not be asked to write any code. Okay, but we discuss some definition. We discuss what is an action, discuss something in the lecture. Yes, what is an event? What is an event handler? Give an example of event and event handler. Yes.
Is it good to review the slides?
Yes. You can review the slide, but most importantly, practice programs. Okay, there will be some true-false question. If you can program that was easy. But if you do not program, then that's difficult. But there is an advantage of having true-false, right? You have a 50% chance to get correct. Either if you say all true, then at least 50%. Maybe, that may not be. But if you understand this concept, actually whatever these test 2 is the main, the principle about the object-oriented principle. If you do good in test 2, that means you understand object-oriented programming principles. So you know a room will be compact. You know, so this is a hard question. Is some you will not have time to look at next to the person next to you. Okay, so you have to utilize your own brain. So still you have time. Just practice these 5-6 programs. Okay, do not copy. You can see my code, but do not copy and paste code. Practice. Okay, like for string operations, we discussed that how the string works with the println method or right line method. Everything becomes strings, right? Number becomes string. If you concatenate a string and a number, then as soon as it gets a string, then everything becomes string. And there is a difference, some difference between the substring method between C++, C# and Java. Only the substring method if the starting index does not start with 0. That's the difference coming. So just practice this, okay? Practice this programming, then you should be good. Anyone has any question about test 2? Yes.
Is there any chance you can tell us how many questions are going to be like?
There will be 6 questions.
Well, no, what I meant is like, is there any chance you can tell us how many questions are coding as opposed to definition of true or false?
No, so you will have 3-4 questions for coding. But coding is like only few lines of code. If you understand how to declare an abstract class, right? So we will have a method, simple method. Then you inherit that class. In the concrete class, you will have to put the body. Okay. Just I'm telling you everything I discussed, but there will be whatever I discuss in class, but your class name will be different. Whatever I said, for instance, I discussed with vehicle class, right? If you understand abstraction with vehicle class, you should be able to do it with an animal class. You should be able to do it with a furniture class, right? You should be able to do it with books class. You should be able to do it with human class. Just look at the class name. You will declare the class name, right? Exactly, and then some. Just practice programming, please. And if you do well in test 2, you should be able to crack a job interview. There are some questions that I discussed, that possible test question, possible interview questions. So tonight we will finish early, okay? So let us see that we have mainly another part, recursion, part 2. So in our last lecture we discussed a recursive method, right? And the recursion function. What is a recursive method? When a method calls itself, then it is called a recursive method, and the process is called recursion. Okay, a recursive method calls itself is infinite time or a certain time. A recursive method calls itself in a certain time, certain number of time. Okay, a recursive method actually converts to a point, base. Okay. For instance, finding factorial of a number. We say factorial of n equal to n into factorial of n minus 1. Okay. So some students, they confuse about factorial of n equal to n into factorial n minus 1. They think that this is divergent, not this convergent, right? N minus 1 is less than n, right? Okay, since n is a positive number. So we consider base equal to 1, factorial 1 equal to 1, or we consider base equal to 0. That means factorial 0 equal to 1. Okay, let's see. There are a few slides over here. Let's see how these work. Okay, so a few slides. Let me go to these slides. Okay, so in our last lecture we discussed factorial, how to find factorial of a number recursively. So there are some other recursive method. For simple example, recursion is not required. You can technically use a loop. For instance, we know that we can find factorial of a number using a loop, for loop, right, or a while loop. But it is easy and faster to use a recursive method. So there are many implementation, for instance, for recursive method. For instance, from after our test from next week, we will learn how to implement a stack or queue, then linked list. All this work recursive way. So you need to understand recursive way. This is simple way, there is nothing complicated, but you just understand the base, then you'll be fine. For many operations, for instance, file operation, file handling, we use recursive process. Okay. These are the rules for an advanced recursion, and I want to say, okay. For instance, this program, okay. So here you see that this method name is do work, and it is here it is calling do work itself with two different argument, right? So that means we can, this process is called divide and conquer method. So we divide a large task into at least two smaller tasks, and every time we divide each of the smaller tasks into another two. So this is why, for instance, if you have a very large set of numbers, you can divide in half from the middle with the middle index. Then you have two smaller list, and then for instance, there is a popular way for merge sort. Merge sort that takes less amount of time than other kind of sorting algorithms. So we implement those like recursive way. So maybe we'll discuss merge sort in our review time. So for instance, here, what is my base case? Can anyone please tell me? What is my base? When this recursion will stop?
I is 2 or less.
Yes. So as long as I greater than 2, it will be recursive, and as soon as I less than or equal to 2, actually equal to 2, then it will stop, and then it will not go negative. So hopefully this program, if you run this program, you will get an output something like this. So let me see the next one. Another recursive method is recursive Fibonacci method, Fibonacci series. We discussed maybe in last moment in our last lecture. So a Fibonacci series is a mathematical series that start with 1, and then it works with that in a way that the third number is the sum of previous two numbers. So the recursion implementation of a Fibonacci series will be, if I equal to 1, then return 0. Some people argue that Fibonacci series start with 0. So that is the 0 it will be returning. Otherwise, if I equal to 2, then it will return 1, the second number in the series. Otherwise, it will call itself, the Fibonacci method is called will itself with two different arguments. You see the Fibonacci of I minus 1 plus Fibonacci of I minus 2. If you understand this problem, this implementation, okay, you should be good to understand any recursive method. Let us see how this works. So we have set up how many bases over here? How many base cases over here? 2. What are those? I equal to 1 and I equal to 2, right? These are the two base cases, right? Okay, remember that. So for any at any time, if this part or that part, actually these part are embedded within the main method, right, within the Fibonacci method. This part or this part, either of this part gets I equal to 0, sorry, I equal to 1 or I equal to 2, then it will return either 0 or 1. Otherwise, what it will do, it will call itself. For instance, let us see that if, okay, I will show you in a live method. Then another example of a recursive method is string processing. We can reverse a string by recursive way. This is an interview question. Okay. If you do well in the job interview for the first round telephone interview, for some next time for coding interview, they may ask this kind of question. So for job interview, practice string operations. You will get 1-2 questions for string operations. String operation is important. So how do we do reverse a string? So if a string is empty, then nothing to reverse. But if a string has only one character, then nothing to reverse, right? One character is usually printed. But if it has 2 characters, more than 1, that means how can I get that a string has more than 1 character? We know the length method, right? Yes. C# has length and it's called attribute, and Java has length method. In Java, it's length, L is in lowercase and then parenthesis. Okay. So is length equal to 1, or even you can say is less or equal to 1. You can use both. Then it will return the same string, right? If s dot length equal to 1, that means only 1 character of a string, then it will return same thing. There is nothing to reverse, right? Otherwise, what is the next part? Otherwise, else, return reverse method, it will call itself from s dot substring 1. What is meant by this? Anyone knows this? Karen, you know? What is this? Substring 1? After?
It goes to the end.
Yes. Yes. Yes, it starts with the position 1. That means it just will skip the first character, right? First character has index 0, right? And then second character has index 1, right? So it will just keep the first character and it will start from second. So when it comes to this condition, when it comes to the else part, definitely string length equal to at least 2, right? At least 2, otherwise it will not come here, right? If it is 1, then it will come here. Otherwise, it will arrive here only the string length equal to 2 or more, 2, 3 or 4 or something, right? Then at this case, it will call itself with by just skipping the first character. It will call all the character remaining except the first character. Yes. Okay, substring, if you start with substring 0, it will not work. Try it. This is a good question. Try at home, okay? Try run this program and try to do it with string 0. And what is the last one? This one? That will give you the first character.
Yeah, substring 0 would give you the whole string. Substring 1 is everything except the first.
Yes, substring 1 will give you everything except the first character. But we need to put the first character all the way in, right? So that is the technique, that first character will go all the way in.
But you don't say.
You can say use S0 or character at or index character at 0. Use S dot character at 0. Maybe in some languages has character is dot character at, like in CHAR at. I'm sorry. Some languages like character at 0, that means at this point maybe this one. Some languages like this, but at least it will work. So we know that a string is also an array of character, right? So it will work this way. Okay, so in Java implementation we can use character at 0, and everything is same, right? In Java we have length method, and then in C# we have length is called attribute. So you will be able to code this in your language, in both C++, C# and Java. One more thing, that again in this course you are learning, you have to understand code both in C++, C# and Java. No matter what is your lab course, lab language, okay, we are teaching here both C# and Java. We are teaching object oriented principles with C# and Java. So you are learning two languages over here. So for instance, I would suggest you, if you are lab right now in Java, spend some time to understand at least the basic, then in summer or sometime during the semester break, practice other language. Okay, whatever your program has in one language, convert in another language. Okay, wherever there is a difference between Java and C#, I discuss everything. And sometime, most of the time, I have my code in all two languages. Okay, that is maybe a quiz question or test question. For non-linear purposes, actually recursion is not appropriate. For instance, not here, you will, if we do graph operation, for this course is not included in data structure. We need to data structure course, we will learn this. So, possible using iteration, but okay. Just for now, remember that. So recursion is not applicable for one voice. Okay. For instance, if your program needs to jump from one position to another position, okay, then recursion is not an appropriate way. So maybe in this code we should have some example where is a non-linear recursion. Okay, you know, for each is like a for advanced for loop. In a for loop, for each works only for object. In Java and C# have for each control statement. This is kind of for loop, okay, but for works only for primitive data types, but it works for object. For instance, dictionary directory D is in object over here. In D dot get directories. For instance, this program is code is saying that whenever we copy a folder from one place to another place, right? So how the copy method works? So it gets first the element, whatever the file it has within this folder, it moves. Then again looks at, is there any folder inside? If there is another folder inside, it goes to the folder. Then it looks that, is there any file on that folder? Yes. If there is a file, then it moves the file. Then it looks that, is there any folder inside? It is finding another folder, then it goes another folder inside that folder. So the going inside of a folder, so it goes the in depth of a folder. As long as it go all the way to the inner folders, the recursion process it works recursively. So this is why for counting how many files in a folder has or a directory has, or for moving the files and folders from one place to another place, the recursion process is an appropriate process. Let me see if I give you an example. Okay. It asks you to write a recursive method that how many functions call can go the stack until it crashes. Okay, so we can try with very large number, then that will. So let me go with my some programs that we discussed. This is 1321, 1322. You know how to get my code? All of my codes are in my GitHub account. Okay, recursive Fibonacci number. Let me get it in. Okay, I do have already program. Recursive Fibonacci series in Java. Okay, so this is the Fibonacci series without a recursive method. So without recursive method, that is a for loop over here. Okay, so if we run this program, it will ask me to enter a value. Is it not working? I'm not sure. Okay. Okay, it's slow. So it asked me to enter a number, then 5, I entered 5. So then the first 5 Fibonacci numbers are, I'm not sure why it's not going there. My internet. Okay. Okay, it got it. It asked me to enter a value n greater or equal to 1, then I entered 5. Then it says first 5 Fibonacci numbers are 1, 1, 2, 3, and 5. If I run this program again, then whatever I enter, if I enter 10, then it will give me first 10 Fibonacci numbers. So let us see how the Fibonacci series it works. So here using for loop we can do it. Okay, so we know that, for instance, here if I give 10, so it will give me first 10 Fibonacci number. This will be 55. Okay, so here Fibonacci, in our Fibonacci series, the first number, third number is the sum of previous two numbers. So our f0 equal to 0 and f1 equal to 1. These are our base. These are the base case in our. If we implement this in recursive method, we will use this bases. Okay. So then after that, what is a swapping? F1 equal to F0 and F0 equal to F. The third number will be F0 plus F1. It is updating just F1 and F0. And it is printing F. In this way it works. So in this kind of program, so the position of this, for instance, this print method is very significant. For instance, if we put this print method here after this, it will not work. So let us run this program. If I want to give first 8 Fibonacci numbers, it's getting 1, 2, 2, 2, 2, 3. Okay, that's good. If it, since if it prints F, then it's good. It's working. But sometime I will show you another program that the position of print method is a factor. I'm going there. Okay. For now, so everyone understand this, how this Fibonacci series works without a recursive process. So now let us go to a program that with Fibonacci series. Fibonacci recursive example 1 Java. Okay, I need to read Java. This is my Fibonacci method. This is my Fibo method, and then I will call this my main method. So I have hard-coded value over here. You can write code to get it by keyboard input. So it's n equal to 10. If I run this program, it will give me the first 10 Fibonacci numbers. Sorry. This one. Okay. Okay, the first Fibonacci numbers, okay, 10 numbers are here. So, how this method works over here? So, we know that we discussed that we have two base cases, right, for Fibonacci. So, the both base cases we can write here together. There are two base cases over n is less or equal to 1. For instance, we have another base cases. If we say n equal to, so else if n equal to 2, then second number will return 1, right? What is our base cases? Fibonacci series. Okay, for 2 it will also return 1. So I can write base cases like two base cases, or I can say one base case. That should fine. One, oh sorry, it does not work. Why? Is this true? Not true. Okay, it should be true. Okay, so there is a mistake in our code. It should be true. Can you make this correction, please? When you're getting not, please be true. Because here for n equal to 0, this is the 0th 1, and 1 equal to 1, and for 2 equal to this 2. Okay, so then now C++ people will be able to convert it in C#. Let me convert it into C#. So in order to convert this method in C and C#, what changes we need to do? We can just put our code over here, and then this one we need to change system.out.println by that's it, we should work. Okay, so then not line actually print, right. Okay, practice this. Okay, I have code in both and C# and Java. So the last one I want you to practice recursive string reverse. Okay, so in our last lecture maybe we discussed a factorial method, right, that can be implemented in multiple ways, right? So here the recursive method for string reverse, it can be implemented in multiple ways. So for all of this, actually the last thing is that, so we reverse is dot, we call substring 1, and then this one. So there are some changes over here where you will consider the base. You can base as empty. If it is empty, then it will return empty. Or you can base say is base, that will be s equal to null or s dot length equal to 1, less or equal to 1 character. Then it will still return. Then there is another way. There is another way. Actually, there is another way. There are multiple ways to do string operations, string reverse. Okay, but recursive string reverse, I'm giving this code in Java. Recursive string reverse methods samples Java. And also C#. So for the Java one, I want to copy my code from This is my main method. This is my main method, and these are my, I have multiple recursive methods. These are my recursive methods. It should go after main. We know that we cannot declare a method within a method, right? We can declare a method outside a method, but all will be inside the class. Okay, so I have worked with only a small string like hello. Then if you use hello world, it should also work. So if I want to convert this program in C#, where do we need to make changes? How many changes we need?
Change the print lines console.write line.
Yes, then everything should be same, right? So you will be able to do it. Okay. I just gave my code in C, in Java. Please, people who are in C#. Actually, everybody needs to understand C# and Java. So you can get my code and convert this. So actually, I can do it quickly. Let us do it. And then I can do it quickly. So I need to change this method. So another thing that in C# we use string s is in lowercase, right? In Java we use uppercase, string s is in uppercase, but in C# usually, ideally, it is in lowercase, but if you can use in uppercase as well as. So usually in lowercase. So if you use lowercase, then you see that it is. Okay, so character does not exist. Line number 71. Line number 71. Okay, this method is different, right? To string method, it is T is in uppercase. Also, okay, you need to make changes. Also, L length is an attribute, so you need to make L is in uppercase, and there is no method. So Caesar, maybe you can help me, right? Okay, so I could not finish. Okay, so substring is should be uppercase, and there is no character. So whatever 2 character, okay, you need to convert. Okay, so convert it, okay, and send me your code, then I will replace it. Okay. Okay, one more program. One more program. I want to. So all of these programs are in my GitHub account. So how to find string length recursively? I have my code over here. So in order to count the string length of a method, we need to add 1. That's the last character. Similarly, we are calling substring, and then we are adding 1 for the first character. Since we are skipping the 1 character over here, right? The first character is skipping here. In order to get all methods, we need to start with substring 0, right? But we are starting from substring 1, that means we are skipping the first character, right? The length of first character is 1, right? So then we are adding this 1 up in order to get string recursive string length count. So let me get this give you this program in Java recursive linear example 1 Java. Here is my main method. Here is my main method, and here is my method. Okay, so in your test 3 you will get some problem with recursive method. Okay, the so far whatever the program I am discussing over here, you will get 1. Tonight whatever we discuss, you have to write, you have to understand this, and then you will be asked to write a program code, not in pseudocode. Okay, and your test code, test 2, you don't have any scope to write pseudocode. Okay, you have to write actual code. So here, so now C++, Java people who should be able to convert it in C# people should be able to convert it in C#, right?
Yes.
Okay, so let me do it in 1 minute. C#. Okay, and then we need the main method. We need the main method, and we need this one. We'll go outside of main. We'll go here, and we need to convert this to this, and we need to convert substring h is in uppercase. (21). Okay, string does not contain is empty. Okay, so length equal 1 equals 0. Okay, got it. So practice this. Okay, practice this, then practice that program tonight I discussed. You will get at least 1 question in your test. So anyone has any question about Okay, can I have 2 more minutes, please? Can I have 2 more minutes, please? I skipped something I forgot to discuss. I skipped something. Can I have 2 more minutes, please? Okay. So as I mentioned sometime earlier, that the position where you will put the print method is an important factor. Okay. For instance, here. Okay. So if we put over here what does this program do? Okay. So this program is recursive ascending order print. Let me get it in Java quickly. Example 1 Java. Okay. Just 2 minutes, give attention please. Okay. So in this program is very simple program. Okay. So what we are doing over here, for instance, we say we the work, this is my method name. Whatever I give the method name is not a factor. Okay. So if I say n greater or equal to 0, then it is printing n plus some space. Okay, and then it is calling itself. Okay, so let us understand what this recursive function does. Okay, so here, for instance, if you call this method by itself, okay, so then what will happen? It will call with 10 factor 10, so that's n equal to 10 is greater than 0, right? So then it will print 10 first, and then it will call this method with 9, right? And 10 minus 1 equal to 9, and then next second phase it will print 9 and it will call this method with 8, right? So how long it will go? It will go, so it will be printing 10, then 8, 9, then 8, and then it will be ending where? As long as greater or equal to 0, that means it will be end at 1, right? Yes, 0, right? Okay, 0. So here, so let us see. Very small program, but it has a significant element to understand. So it is going to the 0, right? So look at that here. How about if I do not print the n value over here, but if I print the n value after this, what will happen? So in this case, let us see, remember the previous output, it is getting descending order, right? So but this time it will get ascending order, because what will happen, so whenever it comes with 10, then it will call itself by 9, 9 will call itself by 8, 8 will call itself by 7, and it will go all the way to 0. And when it reaches to 0, then it will start printing. Okay, and then it will print the last, it will print from reverse order, it put on the stack. Okay, so this is why it is getting from 0 to 10. So you understand the difference between if I gave this statement above the recursive call or below the recursive call. Output is completely different, right?
Yes.
Okay, so this program, it will work for ascending order. Okay, and but if we want to print descending order, what will be your technique? You need to put print line first. Okay, so this is why my program over here, it is called ascending. And if I write another program that I want to give name descending, Okay. For the descending order, my program is completely same, exactly same, but what is the difference? My program is completely same, right? This is my descending, but what is the difference?
You put 2 public static voids.
This is here in descending, okay? And then I will get my descending output here.
You has 2 public.
Oh, I'm sorry. Yeah, I have 2 public methods, so I need to delete one. Thank you. So you understand how can I print a series in descending order or ascending order just by changing the position of my print statement. You understand? Okay, now I have a question. If I want to print 0, 1 to 10 and then 10 to 0 again, then what do I need to do? If I want to print 0, 1, 2, 3, 4, 10, then again 10, 10, 10, 9, 8, up to 0.
Print statement before and after.
Yes, that's good. If I give another print statement over here, then it will print from 10 to 0 and then again 0 to 10. See the output? From 10 to 0, this for first part, and it is getting 0 to 10 for the last part, okay? Thank you so much, and everybody please be prepared for the test 2. Good luck. And bring your ID, please. For test 2, bring your ID. Do not forget your ID. And thank you so much. You have a good night.
Sorry about it. I've got a few. I've got like a few. So you said that like one that was probably going to be true or false. I don't remember what exactly you said.
True or false about the perspective of abstraction, interface, constructor. If you know the definition, then you will be able to.
Okay, so that'd be more in the definitions.
Definition and programming
As
techniques.
opposed to practical.
Yeah, practical.
Okay. So and